Stateless Dynamic Host Configuration Protocol with IPv6. In this MicroNugget, we'll take a look at how a DHCP server can be used not to hand out IP addresses, but simply information like DNS. Let's begin. Our objective in this MicroNugget is simple. It's to take a look at the router advertisements and the effect that the M and the O bits have inside of that router advertisement. Now, to put us on the same sheet of music, we probably ought to begin by taking a look at what the heck is a router advertisement to begin with, and then we'll work our way to the M and the O bits respectively. So let's take a look at IPv6 when a client first of all connects to the network. When the client connects to the network, it has the ability to automatically discover what network it's connected to and then automatically configure its interface ID or host ID on that network. So we don't really have to use DHCP whatsoever. Now, the magic behind making that work is that when the client boots up to the network, it sends a router solicitation. Like, hey, I need to know network information. And the router, in response to that, sends a router advertisement. Inside of that router advertisement, it's magical. It's got the network information. So now the client listening to the router advertisement can say, oh, I'm connected to the 2001 DBA 1:0:/64 network, and it knows exactly what prefix or network it's connected to, and it can use that to figure out and calculate its own host ID in combination with that network address space. The bottom line is it can automatically configure a correct IPv6 address without DHCP. So it sounds beautiful, and it is. And this process, by the way, is called SLAAC. It's the Stateless Automatic Address Configuration feature of IPv6. But the big problem, at least for most people, is that inside of this process, inside the router advertisement, it doesn't tell the client exactly which DNS servers to use for name resolution. And name resolution is going to be more important than it ever was because IPv6s are so darn long. So how do we solve that? There's several ways of solving it. One way is we could train our entire network to go ahead and use a DHCP server to learn the DNS information. So it can still automatically configure its IPv6 address, but as a side thought or an afterthought, the client could actually make a DHCP request and say, hey, I don't need an IP address. I've got one, thanks. But I would like to learn about DNS from a DHCP version 6 server. They call this Stateless DHCP. Some people call it DHCP Lite, but that's effectively what it is. We're simply asking for option information, for example, DNS information, and not asking for a full-blown IP address. Now, how exactly do we train a network to do that? And the answer lies in these bits right here. Inside the router advertisements, there are two fields, two bits. They're called the M bit and the O bit. The M represents something called the managed address configuration flag, and the O bit, O as in Oscar, is the other configuration flag. And it goes something like this. If the M bit is set to 1, the client, when it sees that, is supposed to say, you know what? I'm going to go ahead and be a full-blown DHCP client, and it will simply make a DHCP request. If the M bit is set to 0, and the O bit is set to 1, it says, go ahead and do your stateless automatic address configuration. That's fine. But just so you know, if you need additional option information like a DNS server or something else, there's a DHCP server available. You can make the DHCP request for those additional options. So if we simply set the bits like this, M bit to 0, O bit to 1, we can do stateless automatic address configuration for the clients, and they can automatically go and ask for the DNS information, the option information from a DHCP server. It's that simple. To configure this, to make it work, we have to do a couple basic things. Number one, we'll need to create a DHCP pool on our one. We'll need to specify in that pool the IP address of the DNS server they're supposed to use, and we need to tell this interface to make it aware to look for DHCP requests, and for the router advertisements that get sent out of that interface, we need to specify that the O bit is set to 1. Let's walk through that right now. So to configure this in its bare minimum sense, we're going to go into configuration mode and simply create a DHCP pool for IP version 6 and simply specify one entry, and that is DNS server is going to be 2001 DB82::100. That's it. Now we could also do other things like domain name, and if we wanted to do stateful DHCP, we could add the network prefix and so forth. But for basic assignment of a DNS server with stateless DHCP, that's all we need in the pool. Now the second piece of this is we need to go to interface gig 2/0 and do two things. Number one, we need to tell the interface that it needs to send the O bit as a 1 when it sends out the router advertisements. And secondly, we need to associate any DHCP requests with this pool that we just created. So we'll make a little road trip down to interface gig 2/0, and we'll specify that the DHCP pool, for any requests that come in, we associate that with our pool we just created, the our pool, and we'll specify that we got the other config flag, the O bit, set to 1, and that's how we do it right there. And then just to verify the details, we've got our pool called our pool, fantastic. The DNS server is this guy right here. So here's what should happen. The router advertisement should have the O bit set to a 1, which should cause a client to say, oh, I need to go ahead and do stateless automatic address configuration on my own, but then make a DHCP request for any options, such as the DNS server. So we're going to use R3. R3 is going to volunteer as our client. R3's interface is gig 1/0, and we're just going to configure him to do basic automatic address configuration and then verify that he does his own address configuration based on the router advertisement and that he makes a request up for the DHCP-based options, such as the DNS server. So with R3 playing the role of our client, I want to do a couple basic things with it. I want to tell it to use IP domain lookup, because if we're going to hand it a DNS server, I want it to be able to try to use one. I'm also going to wipe out anything on gig 10, and we're going to go ahead and put a MAC address there with a whole bunch of 3s in it, so when we look at it with the protocol analyzer, it's easy to see. And then I'm going to tell it to use auto configuration plus assigning a default route for its IPv6 interface configuration. I've got a packet capture set up right here to look at all the traffic. We'll simply go back and do a no shut, and then we'll go back to the packet capture and watch it go through. So we have some CDP messages, and what I'm expecting is we're going to have some router solicitations, some router advertisements, and effectively this client should go ahead and get an IPv6 address on its own from automatic configuration and do DHCP requests for the actual DNS information. To verify this worked, we could do a couple of basic things. Number one, we could do a show IPv6 interface for gig 1/0 just to make sure it had an IP address, and it certainly does. But how do we verify that the DNS information was really obtained? We can go ahead and simply do a show IPv6 DHCP interface, and that should show us, if we do have the DNS information there, that should show us that it worked. And check this out. It shows us that the DNS server it learned was 2001 DB82::100. To verify that, we could do a test with a ping to some name inside that DNS server. I set one up. It's called test.cbt.com. If that works, that verifies that the DNS reachability works, which is a great thing. So that's our DNS server that we reached. We resolved cbt.com to this IP address, which is over on the 12 subnet between R1 and R2, and because the ping actually worked, it's basically a home run that all the pieces operated together. So if we go back to the trace, which I just stopped, by the way, because it was scrolling up on me, we have the router solicitation that was made by R3, the router. Here's the source MAC address, by the way, so you can see it right there. And it was saying, you know what, I'm looking for a router on this network. Well, in response to this, which is in packet 5, we got a router advertisement in packet 6. And the router advertisement says, yes, you're connected to this network, 2001 DB81::64. And if we look at the flags, check this out. The other configuration bit is set, which told R3 as a client, hey, guess what? If you want additional information, it's available. So what R3 did, it made an information request in packet 12 here, and it says, you know what? I'd like some information. I don't need an IP address. I got one of those, but I do need some DNS and other information. And as a response to that, this is packet 12. If we look at packet 13, we have a DHCP version 6 response. In that response, we have the information of the DNS server it should use right there. It also has the domain search list, which is effectively the domain name of CBT Nuggets that was built into R1. In this MicroNugget, we've taken a look at the router advertisement and modifying the O bit to set it to on to encourage our clients to go ahead and use DHCP for receiving additional option information, such as DNS. I hope this has been informative for you, and I'd like to thank you for viewing.